Hello friends, so this is going to be a quick review on the 4 ways to solve quadratics and also when you want to use those different techniques. So a quadratic equation is anything of the form ax squared plus bx plus c equals 0. So a cannot be 0, you have to have like a squared term in it, and that's really what makes something a quadratic equation. Now, there are 4 ways to solve a quadratic. We have the square root property, factoring, completing the square, and the quadratic formula. Now, each of these has their time and place, and so what I'm going to do is first I'm going to review all of these techniques, and then we're going to talk about how do you choose which one that you would be the best for your situation. So the square root property is actually, it's also a part of completing the square, but it's really vital to know, and it's really obvious when you need to use it. So the square root property is always something that kind of has this form where you have like this little mini expression being squared equal to a number. So it's really obvious to me anyways when you want to use the square root property, because it's the only thing that takes this form. Everything else can be a little touchy, but this one is at least obvious. So to use the square root property, you take square root of each side. So we're not always the most clever in naming things. And so when you take the square root of the number side, you need to throw a plus or minus in front of it. So what happens is that the square root will cancel out the squared term. So on this side, I'm just left with x plus 2. And on the other side, this becomes plus or minus 7. And now that I have that plus or minus 7, that kind of turns this problem into 2 problems. So I need to solve x plus 2 equals 7 and x plus 2 equals negative 7. So you see that plus or minus, that's been reflected here. And so then I just finished solving for x as usual, so I can go ahead and just subtract the 2 in all cases. So I have that x equals 5 is one solution and x equals negative 9 is another solution. Okay, so the other techniques are not quite as obvious. So factoring is probably the fastest and easiest to use, but it might not always be obvious that you need to use it. So here's a situation where I have an equation. The second I notice that something is being squared, usually what I want to do is collect everything to one side. So I'm just going to add 6 to both sides. I'm going to bring this 6 over to the other side so that this becomes x squared plus 5x plus 6 equals 0. Now, I do assume in this video that you know your factoring. In the event that you need to go back and review that, I do have a quick review series on factoring, but I'm going to assume at this point you know how to factor. So the next thing that you want to think after you've got something in this form is, will this factor? And so yes, this will definitely factor, and this factors as x plus 2 times x plus 3 equals 0. And so from here, now I can just finish solving. Now, the idea when you factor is that you actually set each factor equal to 0. Most people don't do this step, but I'll just show it just in case you completely forgot it. So my 2 solutions would be x equals negative 2 and x equals negative 3. So these are my 2 solutions. Now, the thing is, most people don't feel the need to write out this work because usually when they get to this step, they just take the opposite sign of whatever number's here. And that's totally fine. But just in case you ever can't figure it out what it is, you just set the factor equal to 0 and then solve for it. So factoring is kind of your easiest one to do if it easily factors. But not everything factors. And that brings us to the other techniques. So here I've got completing the square. So I've got x squared plus 4x plus 6. This cannot be factored. So you have to use a different technique. Now, there's a little bit of wiggle room as to what makes something the best technique, and we'll talk about that more as the video goes on. But since I can't factor this, I know I'm going to have to do something else. This one is actually a perfect example for using completing the square. So when you want to complete the square, now what you've got to do is you've actually got to have the variables isolated to one side and the number isolated to the other side. And after you do that, the number attached to the x, that is your b. And once you have identified your b, you've really set off like a chain reaction to get completing the square going. So the steps with completing the square are always that you identify your b, and then you always take half of that, so half of 4 is 2, and then you always square that result, and so 2 squared is 4. So this is always what you do to complete the square. These are just the automatic steps that you have to be used to. And the key to this is actually this last part here. So after you get that half b squared, what you want to do is you want to add that to both sides. You want to add it to both sides so that you keep the balance within the equation. So what this turns into then is x squared plus 4x plus 4 equals negative 6 plus 4 is negative 2. Okay, so now this side here needs to be factored. And it needs to be factored as a perfect square. Now, in the event that you're not sure how to factor this, the half b term is always used to factor. So the way that this expression here will factor on the left side is x plus 2 squared, and that equals negative 2. So now I've got x plus 2 squared equals negative 2. And now I can finish this. So now I'm going to use the square root property. And I'm assuming that if you're watching this, by the way, that you also know your imaginary numbers. So if I take the square root of both sides, this now becomes plus or minus the square root of negative 2. And then you just simplify this as much as possible. And since this is a negative under the square root, that is an imaginary number. So this becomes x plus 2 equals plus or minus I times the square root of 2. And so then to finish this, I can just subtract off the 2. So this becomes negative 2 plus or minus I times the square root of 2. Now, I could break this off into the plus case and the minus case, but since I can't like really add these aren't like terms, I'm just going to leave it like this. I will say that some homework systems require you to break up these two cases into the plus case and the minus case. So if you have to break this up into two pieces, that's just something to watch out for. So that's completing the square, and the whole thing with it is kind of this b thing, and then adding that half b, boom, boom, to both sides and factoring. The other method is the quadratic formula, which is honestly my least favorite of the methods, although I know a lot of students like it because they're just like, oh, it's the quadratic formula, it's just this thing. Okay, so here's the thing with the quadratic formula. This is like a lot. This is a lot to do, okay? So sometimes it is the only way to get the job done, but it is just, I'm just saying, it's not my favorite. Obviously, I've got to use it, but it's not my favorite. So let's talk about using the quadratic formula in this case. So to use the quadratic formula, the key is that you have to have all your terms on the same side, which we do in this case, so we're good to go. So as long as all your terms are on one side, then you just identify what's your A. So in the A position, and by the way, where does that A, B, and C come from? So that comes back from here. So your A is always what's attached to the x squared, your B is what's attached to the x, and then your C is that freestanding number. So that is directly related to the quadratic equation form. So in the A position, I have a 1. In the B position, I have a 4. And in the C position, I have a 6. So now I'm just going to plug everything that you see or that we just identified into this formula here. So you can pause the video if you want to write it down. So this is going to become x equals negative 4 plus or minus the square root of 4 squared minus 4ac, so that's 4 times 1 times 6, all of this over 2a, so 2 times 1. So there's me plugging everything in. Okay, so at this point now, I just have to follow the order of operations. So if I go through this is going to be negative 4 plus or minus the square root of 16 minus 24 over 2. Okay, so now I'm running out of space. And this is another reason I don't like the quadratic formula. It takes up too much space, dang it. Okay, so let me make some more space. And now we can keep going. So this will be negative 4 plus or minus now the square root of negative 8 over 2. Okay, so now I have to break down this radical. It's got a negative in it, so obviously I'm going to have to bring an I out. So this is negative 4 plus or minus I times the square root of 8. But then I can also break down the square root of 8. So I can break this down as to negative 4 plus or minus I times 2 times the square root of 2 over 2. So ultimately this looks like negative 4 plus or minus 2i times the square root of 2 over 2. Now, the other thing that you just want to be careful of, the fatal blow I always notice with the quadratic formula is that people get to this step and then they cancel everything wrong. So to avoid that, remember, this 2 goes for everything up here. So avoid getting cancellation happy and force yourself to break this up into 2 separate fractions for a moment and then cancel out your 2's. Because now that I've broken this up, I can see that negative 4 over 2, that equals negative 2. And then in this other case, these 2's will cross out. So this becomes I times the square root of 2. And so here is my answer, negative 2 plus or minus I times the square root of 2. And hey, wasn't that exactly what we found back here when we completed the square? And so this brings up an excellent point then. Which was the better technique? This is always the question. Which technique do I choose? Well, it totally depends on the problem. So there are a lot of problems where you can use any of the 3 techniques and you should get the same answer every single time. But like some people might look at a problem like this, so 2x squared plus 5x plus 3. So this can be factored, but there's a lot of people that look at this and say, I don't see how this can be factored. Now, for me, of course, you know, I do math more than any person probably really should. And so for me, I can look at this right away and say, oh, sure, that factors as 2x plus 3 and x plus 1. And maybe even for you, you're like with a little bit of time, you would have figured out that same thing. So this is definitely the fastest way to do this particular problem. But, you know, it might not jump out at you. And so while I would say, yes, factoring is the best thing, if it doesn't work for you or if it's not what's jumping out at you, then use something else. Now, what's interesting though is, sure, I could also use any of these techniques. So I could use completing the square here. But there's one other thing with completing the square that would make it, using it kind of suck in this particular problem. So the key for completing the square, so with completing the square, you have to have a quadratic that's of this form, x squared plus mx plus n equals 0. So I chose slightly different letters for this, just to illustrate the point that the key with completing the square is that you need this to be just x squared. You cannot complete the square unless this is just plain old x squared. You cannot have a number in front of the x. So in the event that you don't have that, what you can do is you can divide everything by whatever number that you have, but sometimes that makes everything kind of suck. And this is exactly one of those cases. So for instance, if I set this whole thing equal to 0, so we're trying to really solve this quadratic here. Okay, so think about dividing everything by 2. So I divide everything by 2, so I get x squared plus 5 over 2 plus 3 over 2, and this is going to equal 0. Okay, oops, and this should be 5 over 2x. Sorry, my bad. Okay, so now think about what we have to do next. So then I have to isolate this side, and you're probably already feeling uncomfortable because this has fractions, but then we have to identify our b, right? So my b in this case would be 5 over 2, and then I still have to take half of that. Now, that is not the worst thing to have to take half of that and then square it, so I get 25 over 16. But it also just depends on your strengths. So if you're a little bit weak on fractions, having to like introduce completing the square might not be the best, right? Like this might not be fun. And so this might be a case then where completing the square is not the best, versus maybe the quadratic formula would have been ideal for you, because looking at this, so if I set this up as a quadratic equation as 2x squared plus 5x plus 3 equals 0, well, then I'm going to have my a will equal 2, my b will equal 5, and my c will equal 3, and then I can just plug that in. And for the sake of time, I'll just show you what it looks like to plug that all in. We'll go boom, like that. And so now you can see, okay, I can work all of this stuff out. And if I continue to work this out, next I'll have this. And so all of this will simplify into the solutions -3 over 2 or -1. And if we compare that to earlier, so remember when I found these factors? So if I set this equal to 0 and wanted to finish solving this. So what I would do is I would set each factor equal to 0. And so then I could just solve for x. So this is x is -1. And then this is 2x equals -3. So I have x equals -3/2. So yeah, this is the same answer, right? So this was a much faster way to find this answer, was to factor. Versus over here, I did the whole quadratic formula. But I did get the exact same solutions. And if I wanted to complete the square, I would also get the same solutions. It's just that it would be a lot more work. And so it's just kind of dependent on what you're comfortable with. And honestly, I do math all the time, and I probably wouldn't use completing the square if I had the choice on that previous problem. So the other question is, do you have to know all of these techniques? So it depends on the context. So you can technically solve any quadratic with just the quadratic formula, but that will take you a lot of time, and so then knowing some other techniques might be helpful. Also, depending on what math class you're in, you might want to know all of them very well. So it really depends on why you're forcing yourself to review this material, in terms of which ones you need. At a minimum, you really need to know the square root property and the quadratic formula, but I would say knowing all of them is going to make you a much stronger student. So the next thing, and really the last thing that I want to talk about in this video, is I want to talk about choosing the optimal technique. And what we're going to do is we're going to use each method only once. So what I've got here is I've got these 4 problems. And there is a best method for each out of the 4 that we've talked about. So what I want to suggest that you do is I want to suggest that you pause here and actually really think about this for a moment. Maybe spend some time trying out some of the methods and seeing if you can figure out which method is best, and then hit play when you're ready. Okay, so I'm just going to walk you through how I think about these. So the first one that just jumps out at me right away is the square root property, right? So it's that one where we've got the squared thing equals the number. That is just like the slam dunk, easy one to pick out. So that one is the square root property. So then after that, we have to kind of start thinking. And the next thing that I look for is, what can I most easily factor? And the nice thing with this particular set of problems is everything is already collected to one side. So I can actually tell just from, knowing some things about factoring, I can figure this out, how to factor this right away. So I'm going to use factoring for that next one because it's most easily factored. Now, for these next 2, there is actually a best choice. So for B, we'd want to use completing the square here. And the reason why is, so remember, the term that is attached to the x is our b, and we have to take half of that. So ideally, what we would like is we would like for this to be an even number. Additionally, remember the other thing we said about completing the square, you want this to be just x squared. So this kind of checks the 2 boxes for ideal completing the square. Versus this last one, this has a 2 here, so I would have to start by dividing everything by 2, which is not ideal. And so this last one is going to be ideal for the quadratic formula. So let's go ahead and now solve all 4 of these, which, by the way, if you are using this to actually review for whatever purpose, I would see if you can just do these 4 on your own, and then you can just watch the solutions. Remember, math is not a spectator sport, so you will do a lot better with this if you actually just pause and try it yourself. Even if you get it wrong, that's fine, you'll learn more. Okay, so I'm just going to jump into these then. So this first one, like I said, this will factor all day long. So we will just factor it. And so then my solutions are going to be x equals -3 and x equals -4. Bada bing, bada boom, no problem. What you got? All right, let's move on to B. So for B, like we said, this was completing the square. And so the first thing that we're going to want to do is we want to just get the variables isolated to one side. Okay, so now I need to take this part here. This is my B. My B is 8, so half of that is 4. And half of that squared, so 4 squared, is going to equal 16. So that 16 has to be added to both sides of this equation. So this is going to be x squared plus 8x plus 16. And then on this side we have -1 plus 16, so that will be 15. Okay, now from here I'm going to go ahead and factor this. So this will factor as x plus 4 squared equals 15. Now remember, if you aren't sure what number should go here, you can always just refer to the half b, and that's the number that's going to drop in here. And from here, now I can use the square root property. So I'll take the square root of both sides. So this becomes x plus 4 equals plus or minus the square root of 15. And so then I can subtract off the 4, so I have x equals negative 4 plus or minus the square root of 15. The square root of 15 cannot be simplified any farther, so we will just leave that alone. Okay, next up we have the square root property, so we can just go ahead and jump right into this. So I can go ahead and take the square root of each side, this will be plus or minus on this side. So this becomes 5x minus 1 equals plus or minus 8, right? The square root of 64 is 8, so now I can break this into two separate cases. So I'm going to have 5x minus 1 equals 8, and 5x minus 1 equals negative 8. So I'm breaking this into two separate cases because I can easily collect terms and get a final number answer. In the case where I have a weird square root or an imaginary number, then I wouldn't break it up. So now I can go ahead and just add the 1 to all sides. So I have 5x equals 9 and 5x equals negative 7. So x equals 9 over 5 and x equals negative 7 over 5. And so that will be the answer for those. And finally, we have the quadratic formula. So we need to identify what's in the A, B, and C position. So for the A position, I have A equals 2, I have B equals 1, and I have C equals negative 5. Now I will just flash this on the screen one more time in case you need to take a screenshot of it or write it down or whatever. But here's the quadratic formula one more time. So I'm just going to go ahead and just use this right away. So this is going to be negative b plus or minus the square root of b squared, so 1 squared is just 1, minus 4ac over 2a. So there's everything. Okay, so this is going to be negative 1 plus or minus the square root of 1 plus 40 over 4. And so we're actually reaching the conclusion of our answer very quickly. So this will be x will equal negative 1 plus or minus the square root of 41 over 4. And so I can either leave that as is, or I can break this into two separate fractions. But the square root of 41 cannot be broken down any farther, so that's really as far as I can take that one. Okay. So I try to keep these review videos short, but you might feel like you need to see or do more examples to master this material. And so if that's where you're at, don't worry, I've got you. So every review video comes with a practice problem set. And so the practice problem set includes a PDF of problems with an answer key, and then also worked out video solutions. And so it's all free at divideandconquermath.com. Just go to the review section, or you can check out my YouTube channel, and I've got all my playlists all organized and everything. But remember, you can't learn math by watching a ton of YouTube videos. You do have to practice the material to master it. So please feel free to use my other practice materials if you're trying to master this. And my review series has many other topics in it. So each topic includes a refresher video, practice problems, an answer key, and then the worked out video solutions. So it's all free to you. Just go to divideandconquermath.com, go to the review section. I'd be happy to help you out with more of your math. But I am going to leave it at that, and I hope to catch you in another video. Bye!